Okay, hi everyone. How are you doing, guys? So, welcome to the day two of Network Journey SDN Orchestration boot demo class. So, my name is Shank and I will be your instructor for this course. So, today I've seen some other names of the participants. So, how many of you are joined for the first time, guys? So, not present yesterday because this is the day two. Can you please raise your digital hand? Those who are joining for today, like those who joined today only, not yesterday. New one. So new people, kindly raise your digital hand. Okay, two peoples. Who else? Okay, okay, who else? Okay, so four people are new joining for today's session. So let me introduce myself. So my name is Shank and I am triple CCI certified, CCI in routing, switching, data center and service provider, having total years of 13 years of experience and work in both the organization, whether it is enterprise or service provider company. And I started my journey from the network engineer administrator role to the network engineer to the solution architect. I also worked as a pre-sales and cloud consultant as well. If I talk about technology wise, so I worked almost on all the technologies related to data centers, service provider like MPLS, BGP, L2, L3 protocols, your SD-WAN, VXLAN, VBlock, ACI, ASA, LIPS, all the technologies. Okay, guys, so that's about me. For next 5 minutes, I'm gonna explain you briefly about what is this combo batch about, because yesterday we last 1 hour we yesterday we done it. Okay, so I'm just gonna repeat it in the next 5 minutes, and after that, yesterday we have decided for the 4 topics. So I'm gonna start with the topics immediately. Okay, so for new people who joined only today, so I just tell them about the course content and all, and then we're gonna start with the topics. Okay. So just let me share the screen. Just a second. Okay, guys. So this is a page in the Network Journey websites where you can go and check out the combo batch. This is a combo batch for Cisco ACI, Cisco SD-WAN, and Cisco NEXUS, which is a 3-in-1 combo package. Okay, the batch is gonna start from the next week, 6 p.m. IST, and we are at GMT plus 5.5. Okay. The first module that we're going to start with is the Cisco Nexus module. After that, we're going to decide based on the enrollment of student that we need to start with ACI or we need to start with SD-WAN. Okay. This is the complete course content. In course content, you will have the theory part as well as lab part. Okay. So you can read about that. Yesterday, I told in a lot of detail about these contents. Okay. So we will have a theory as well as lab. Okay. And so this is for ACI. Then for SD-WAN, again you will have a theory and lab portion. Okay, so again we have a complete dedicated lab workbook that is available. Okay, yesterday I have shown those things as well. And then NEXUS also we will have a theory and lab. Okay, so format is like I took the theory lecture, then I show the lab how to do the practice lab, and then you will have the lab access on our servers on which you can do the labs as well. Okay, so lab is available 24/7 till the course end. Okay, so every module lab is gonna open when I start the module, and it's gonna close when I finish the module. Okay, in case if you are lagging behind, you can take for 15-20 days extension free of cost. Okay, so there will be no charge for that. And we are having a dedicated lab instructor and dedicated support team to support you in case you are having any issues with that as well. Okay. And workbook we also going to provide you. So we have a dedicated portal over which you will get the workbook. Okay, so for this on the same website, you once you enroll in the course, you will get the login links and all, so that you will get all the things. Okay, so this is all we are having. Anyone having any question from the new people? Okay, so 4 5 people who joined. Do you have any other question before I start with the topic of the days? Okay, for course fees and enrollment, you will get a link in the chat. Okay, you can directly ask on the WhatsApp numbers, or you can do the email as well. So soon you will get a link in the chat. Okay. Okay, so if you not have any questions, so let's start with the topic. So yesterday we have decided that we do the basic of SD-WAN, basic of ACI, like what are the why we use these technologies, and in NEXUS we will do the basic of VPC and VDC. Okay, so let's start the topics. So let me share. Give me a second, guys. Okay, guys. So let's talk about SD-WAN and ACI first, and then we're going to talk about NEXUS. So let's talk about SDN infrastructure first. So guys, so tell me what do you understand by SDN, software defined networking? What are the main characteristic of software defined networking? You guys can unmute your mic and tell me. So no one knows what is meaning of SDN. I hope you're able to unmute your mics.
Separation of data plane and control plane.
Okay, so one characteristic is your software defined networking is going to provide you is the separation of control plane and data plane, right? What else?
Management.
Sorry?
Centralized management.
And it is going to be having a centralized controller, which is going to do all the controls and management. Okay, so there are other characteristics as well, but these are the two important characteristics of your any of your SDN networking solution. Okay, so if we talk about SDN solutions, it is divided into three spaces, and every vendor is making a solution for all these three spaces. Okay, so first is your SDN solution for data center. Okay, second is your SDN solution, let's say for WAN side, and then you will have a SDN solution for branch side. Okay, so now here in as a part of this class, we're going to talk about the SDN solution for Cisco as well, Cisco only. Okay, but again, you will have all the companies are having different SDN solution for different areas. Okay, which is DC, WAN, and branch. So if we talk about DC, then the solution for SDN is known as Cisco ACI, which is application centric infrastructure, and the controller that we use to manage it is known as Epic. Okay, the solution for your WAN side is known as Cisco SD-WAN. Okay, previously it is Viptela SD-WAN, but Cisco acquired Viptela and now they are rebranding it to the Cisco SD-WAN. Okay, and then you will have the controllers here, which are three controllers, which is one is vmanage, another one is going to be vsmart, another one is going to be vbond. So again, we're going to discuss about what is these controllers. Okay, and the solution for your branch is going to be Cisco SD Access, and the controller is going to be DNAC. Okay, so let's first talk about SD-WAN. Okay, then we're going to talk about ACI. Okay, and then we're going to talk about NEXUS part. Okay, guys, so related to WAN, if we talk about, so I have a question, why we use WAN? So tell me, guys.
Shank, we use LAN in order to connect the remote sites.
Okay, so to provide the connectivity between your remote sites or your headquarter or data centers to your branches, right? We use WAN. Okay, what are the ways to connect WAN infrastructure?
It's MPLS, then VPN, different types
So
of VPN.
MPLS, what else?
Yeah, side-to-side VPN, DM VPN.
So DM VPN on all that stuff is your in the overlay. So here we talking about the physical connectivity,
Okay,
not any type of tunnel. Okay, so yes, so lease line.
VPN MPLS.
What else?
Use 5G or 4G wireless.
LTE, 4G, 5G. What else?
VSAT.
WiMAX, VSAT. What else? Okay, so these are some of the ways via which you can connect it. Okay, so yesterday also I talking about, but let me stress this today itself. First of all, your SD-WAN is not gonna replace any of this physical connectivity. Okay, so this is a myth. Like a lot of people will think that SD-WAN gonna replace your MPLS or SD-WAN is gonna replace your 4G LTE or whatever it is. Okay, so these are the physical connectivity, or you can say as underlay connectivity, which you need. Okay, because SD-WAN is a overlay mechanism which needs underlay connectivity to work. Okay, now how you gonna replace the MPLS through the internet? That is the other part of the story. So we're gonna discuss when we do the architecture point of view. Okay, so first of all, remove this myth that SD-WAN gonna replace your MPLS. Okay, so again, physically it's not gonna replace any of your underlying infrastructure because you need a connectivity. Okay, so for example, if this is your one site and this is your another site, you need a connectivity between them, whether you are going it via different routers or service provider, whatever is the case in between. Okay, so as long as you will have a reachability between your two sites, over top of it you will make a tunnel of SD-WAN. Okay, and SD-WAN tunnels are your IPsec tunnels. Okay, so again, you will have two protocols that you can use. One is GRE, another one is IPsec. So again, you will have a choice. What is the difference between GRE and IPsec?
IPsec is providing encryption, while GRE is not providing encryption.
Okay, so you will have both the options, whether you can go with IPsec or you can go with GRE. Okay, so it will make a tunnel. But as you know, guys, already, to make any tunnel between your site, you need an underlay connectivity because this tunnel exists in the overlay. I hope everyone knows about what is underlay and overlay, right? So you need this tunnel. You need a underlay connectivity, and then you can make it. So now understand why we use SD-WAN, what is the need of it. Okay, so first of all, to understand that thing, you need to tell me at least 10 of the traditional WAN challenges, and you need to tell me quickly. Okay, we don't have much time. I need to cover a lot of things. So tell me guys, 10 or 15 challenges that you are having in the WAN environment.
And bandwidth issues.
What bandwidth issue? Be specific.
Routing protocols.
Sorry.
Unable to run routing protocols like OSPF.
But again, if you are running MPLS, you can run it, the routing protocols.
Time to install new site.
Okay. So new site provisioning. What else?
Expensive.
Sorry.
It's expensive, like traditional.
Okay.
Current,
Expensive, cost. Okay. What else?
Traffic load balancing.
Load balancing. What else?
Security, if expanded.
Security, right? What else?
Management.
Management. What else? Scalability. What else? Come on, guys.
Monitoring.
Monitoring. What else?
Latency.
So latency you are saying. Okay. What else?
Installation.
So new site provisioning, it comes in this. What else?
Troubleshooting.
Troubleshooting. What else? So 2-3 more, guys. Because unless until you not know the issues, you're not able to understand the advantages.
Consistency.
Okay, so consistency, I can say, okay, in your configuration, right?
Correct.
What else?
Easily difficult to upgrade or expand.
Okay, so upgrade. What else? QS. Not application aware. What else?
Commissioning and decommissioning.
So commissioning comes in the new site provisioning itself. Okay. Okay, so I think we are enough with that. So again, guys, these are some of the issues you will find, get it. So let's see how SD-WAN is going to solve this issue for you. Okay, so new site provisioning. So basically, what is going to happen when you do any new site provisioning in the traditional WAN? What is happen? So again, you order a device, it goes to your location. Then what's going to happen after that?
You start configuring, right?
So initial configuration, and then it comes online. Then what's going to happen? Before that, you will do stacking and racking, right? Cabling, racking, all that stuff. After that, it comes and then initial configuration, and then what else? After your it comes, then our L2, L3 is gonna configure it, right? Either remotely or it will be from that office, right? So here there is a process which is known as ZTP process, which stands for zero touch provisioning. So what is going to happen is in the SD-WAN environment, when any of the new device comes up or any of the new site comes up, what it needs is just a internet connectivity. Okay. So when your device reaches to the site and when it got, so again, cabling and racking, you need to do it. Otherwise it will not be able to do it automatically. Okay. So that after that, what is going to happen is it gonna, as soon as it's got the internet connectivity, it's gonna take the whole configuration from the centralized controller, okay, which is gonna present, and then you don't need to do anything. Even you can make the configuration before even your device ship. Okay, so just a second. Okay, so this is known as zero touch provisioning. Okay, which is gonna happen behind the scenes. Again, there is a complete process which we gonna see it in our course how it gonna happen. Okay, so that is what it's gonna do. Okay, related to the expense and cost. So why you think that things are expensive?
You need to license.
Mm-hmm. But where is your cost is going actually?
Procurement, those materials and management.
If it's an MPLS, you have to get a dedicated circuit. With dedicated circuit, you have to take a contract of a minimum term.
Okay, so dedicated circuit related to MPLS, you will got the cost, right? So again, guys, here now it's time to replace the MPLS or dedicated circuit with the internet. But why we not do it before? So what are the advantages of using MPLS over internet? Yesterday I told you 3 advantages. So what are the advantage? So it's gonna provide you security. It's gonna provide you public private addressing, and it's gonna provide you SLA, right? So here what is gonna happen is as you build the tunnel over the circuit, and your tunnels are also IPsec encrypted. So again, it's gonna provide the security. Okay, related to SLA, now you can predefine your SLAs as per your needs. Okay, so there is no service provider involved in that. Okay, so SLA is gonna be as per you can design it directly over the tunnel. Okay, so you will have the control over it. And third one is what? Your private addressing. So again, as we are using a overlay tunnel from one end to another, so you will have you can use your private addressing. Okay, so even on the internet, you can use it like how you do it in the DMVPN. Okay, so now you can negotiate with your ISP, okay, to do the things for you. Okay, so this is how you can lower down the cost. Just a second. Okay, so after that, now let's talk about the load balancing scenario. So load balancing is automatic here in SD-WAN. Okay, so you can shift your load from one link to another automatically. Even you can shift your load on the predefined SLA as well. Okay, you can put some of your traffic over the particular link directly and another traffic over the another link. And once you will get a latency or a delay or jitter or anything like that in your link, it can shift your log automatically via predefined policies. So you don't need to do anything else. Okay, related to security, again, you will have a lot of security mechanisms. You will get the certificates, PKI infrastructure. Here you will get your IPsec tunnel. You can enable or disable services on your edge device. Okay, so a lot of security measures are there. Okay, management. You will have a centralized management of centralized controller, which is gonna manage all of your site. Okay, so whether it can be thousands of sites or 2000s or whatever number of sites you are having, you can manage it via single pane of glass. Okay, from same controller, you can manage n number of sites directly. Okay, scalability is again, you can add site with a new site with a very less time. Okay, with ZTP process, and again, you can scale as much as you can. Okay, and it will be added in your centralized management controller, from where you can do whatever you want to do. Again, your monitoring is again on the centralized controller, so centralized monitoring you can do. So you don't need any third-party tool to do the monitoring for you. Okay, so whole monitoring is there in the centralized controller. Okay, related to latency. So guys, if you are having latency in your underlay, okay, then no one can do anything. SD-WAN can also not do help in that case. Okay, so latency is again, whenever you get the latency in your service provider environment, only service provider will be able to resolve it. Okay, you cannot do anything unless except you put the output from your tool and put it. Okay, so that's the thing. But here, what you can do is in SD-WAN, it can shift your traffic automatically as soon as it gets the latency. So this thing, you can get it from one link to another. It can shift your traffic, or else from one service provider to another service provider within milliseconds, it can shift your traffic. Okay, so this is what you can do, and it will do that thing automatically. Okay, so you don't need to do any, you don't need any intervention. Okay, you just need to configure the policy. For troubleshooting, again, you will have a centralized troubleshooting tool to do the centralized troubleshooting. Consistency in configuration. So here everything is going to configure via a feature which is known as template. So template is a set of predefined configuration, okay, which you set. Okay, so again, it is not like a particular configuration that is gonna given to you. You need to define a predefined group of commands or whatever is the configuration, and it's gonna make it in the one template, and that template you can put it on a number of devices if they are using the same properties. Okay, so through templates, you can put the configuration on different sites. So it's going to provide you consistency as well. It can speed up the configuration process as well. Okay, and it can help you in minimizing the human errors as well. Okay, so templates you will create via GUI method. Okay, so that it will give you the wizard to configure a template, and once you complete that wizard, it's going to create a template for you. Okay, and then you can put it on the edge devices. Upgrade and downgrade. All the edge devices in the SD-WAN environment, you can upgrade and downgrade again via a centralized controller. Okay, so you don't need to go to a particular device to make it upgrade or downgrade. You can do it via a centralized location through anywhere in the world. Okay, QoS is very easy to configure here. Okay, so it is not complex. It is easy to configure. If you know the basics of QoS, you can do it very easily, and it will be end to end. Okay, because your tunnel is end to end. Application aware. Your edge is gonna do the DPI, which is known as deep packet inspection. So it's gonna do the deep packet inspection up to the layer 7, which is it's gonna see the application level up to the application level. Okay, so up to the application level, you can send your traffic over the circuits. So for example, if I am having a particular application, like for example, WhatsApp or WebEx or Teams, and I want a particular link to go the traffic via that. So I can select, I can do that here. Okay, via the single edge. Okay, it's gonna also provide you the security things like via inbuilt firewall, via inbuilt IPS, via URL filtering, via advanced malware protection. So all those features are also present in your edge device. Okay, so these are some of the benefits. Again, these are some of the benefits. As you go with the course, you will get a lot of benefits as well. Okay, so to start with, these are some of the benefits that you get in the SD-WAN environment. Okay, so guys, now there is a company which is known as Viptela. So I'm telling you the history from where this thing come. So there's a company which makes its solution, which is known as Viptela SD-WAN solution. Okay.
Can I just ask a quick question? You know, the slide, would you be sharing the slide, or do we have to take screenshots ourselves?
You can take the screenshot. I am not saving the slides. So if you want, you can take the screenshot.
Okay, I've taken one. Thank you.
Okay. So history is going to be, there's a company which is known as Viptela. Okay. So Viptela is having the SD-WAN solution. Now what happens is Cisco acquired Viptela and rebranded it to Cisco Viptela's SD-WAN. And now it is known as Cisco SD-WAN. Okay. So now if we talk about controllers, you have three controllers in the SD-WAN solution, which is known as, one is vManage, which is in the management plane. Okay, so to manage the complete infrastructure, this is the controller where you're gonna log in. The another controller is gonna be vSmart, which is in the control plane. Okay, so it's gonna use your control plane, okay, to build your tunnels and all that stuff. Okay, and the third controller is in the vBond, which comes in the orchestration plane. So what do you understand by orchestration plane? Can anyone tell me, guys?
Responsible for connection. I'm not sure.
So orchestration plane also is known as security plane. So it's going to be responsible for all the connection, authenticate your devices using certificates and whitelist model. Okay, so these are the three controllers you are having. And guys, if you see the controllers, you will see this small V in front of every controller. Okay, so this V stands for Viptela. Okay, this V do not stand for virtual. Okay, so still Cisco not removed this V. Okay, but this V stands for Viptela. Okay, so do not confuse it with virtual. Although all the three controllers only comes in the virtual form. So they are not physical device. Okay, these controllers are virtual appliances which you can deploy on the hypervisor. Okay, so you can either go with your ESXi. So again, ESXi with VMware or KVM or whatever hypervisor you can put it. Okay, so to deploy this controller, you will have two options. One is on-prem, another one is cloud. So if you go with on-prem, you need to go with the hypervisor, whatever you like. Okay, whether it can be ESXi, KVM, whatever it is. If you want to go, you can deploy your controllers in the cloud as well. Okay, so there are options like Amazon AWS is supported. Your Microsoft Azure is supported. Your GCP is also supported, and Cisco is also provided. Cisco is also provide controller as a service. Okay, where Cisco is gonna manage your controllers in the cloud. Okay, so you can take it. So again, it is an extra cost. You need to do it if you want to take this service, or else directly you can use the cloud as well. Okay, so this is what related to controllers and all. Now after that, you will have the edge devices in SD-WAN environment. So there are two type of edge devices. One is VH, another one is CH. So again, guys, this V stands for Viptela, and they are using these devices is using Viptela OS, which is somewhat similar to Cisco OS, iOS. Okay, but it is little bit of different syntax. You will find it. And this C here is Cisco Edge. Okay, so let me tell you the models. So if we talk about models, we will have VH 100, VH 1000, VH 2000, VH 5000. So again, guys, the difference is in the bandwidth capacity that they can support and other features that they can support. So you can go with the data sheet to find the differences. Okay, so these all are physical. Okay, that comes in the physical form factor, and then in the virtual is also coming, also there, which is known as VH Cloud, but that is only used for testing and whatever is your experiment and all that stuff. Okay, studying purpose, because again throughput is only 10 Mbps here. So that is, you will not use it in the production environment. So production always, the edge device, you will find it to be a physical device. Okay, so this is related to Viptela family. Now if you talk about Cisco Edges, so here these models are only gonna support in the Edge series. So ISR 1100 series, ISR 4000 series, ASR 1000 series. Okay, and there's a new series 8000V as well. Okay, which is supported. And in the virtual form, you will have CSR 1000V. Okay, this is not a V here. So CSR 1000V, which is a virtual device, again, not to be used in the production environment. Okay, so these are gonna be, these are the physical series. Those is gonna support your SD-WAN infrastructure. Okay, so you need to have the model from these series. Okay, then you need to have a valid license, valid contract with the Cisco Smart account. Okay, to get your serials and all that stuff. Okay, so that they can run it. So guys, now 2 minutes time to ask the question if you have any question. Then
Hello.
after this, I'm gonna start with the ACI. Yes, tell me.
Yeah, so you mentioned these devices. These devices are router switches or
So
any
again,
other.
these are gonna be routers.
All
What you put
all
on
are
the edge? Always you put the routers on the edge, right?
yes.
Can you tell me
Okay.
the one reason about for that? Anything which routers support, not the switches? So your netting is not supported by the switches. Only very few series of switches are there which supports net.
Okay.
And guys, I am going a little fast because I need to cover up a lot of things. Again, in the class, I will not go that much fast. Okay. So tell me, anyone having any doubt, any question till here?
So you mean these devices will be supporting netting?
Yes, they also support netting as well.
Okay, and last question. The commands are similar to normal Cisco switches and the routers? Or there is
So
some other
routers,
items?
these are the already what you are running, the Cisco ASR you already running, right? So again, they are running the Cisco iOS.
No, I mean on the VH side.
Okay,
VH
so this is running
100,000.
iOS access. Yeah, so little bit of difference, but again, 90% you will find it as same.
Okay.
Okay. And on the Cisco side, they are running iOS XE. Okay, so all these devices are running iOS XE.
So next generation firewalls also supporting this SD-WAN.
Right now, not, because again, these edge devices are in the inbuilt module of firewalls inside it. So they support firewalls, means they support some of the functionality. Okay, so functionality of firewall also it supports. Advanced malware protection it supports. URL filtering it supports. Okay, IPS it supports. Okay, up to a level. But again, if you need a more function to, then you can connect a firewall with the edge device. Okay. Okay, guys. Anyone having any other question before I move on? Okay, so now let's talk about the other module which is known as Cisco ACI. So ACI stands for Application Centric Infrastructure, which is used for the data centers. So guys, again, traditional network challenges in DC. Quickly.
I think scalability is the first thing.
Okay, what else?
VLANs.
What is the issue with VLANs?
I think that's why we are using VX LANs. The new.
So you need to tell me the issue. Why what is the issue with VLAN?
Sometimes there are not enough number of VLANs.
Okay, so not enough VLANs. Okay, so again, that is not gonna be an issue. Never is gonna be issue for any enterprise company. Okay, that is gonna be issue for service provider only. Enterprise companies, how many VLANs you have seen in the enterprise company?
A couple of hundreds, I guess.
Yes, but again, service provider, as they are gonna service to the different customers, so they need a lot of numbers of VLANs. Okay, anyways, what else? Quickly, guys.
Provisioning new application server.
Okay, so provisioning again, new server. So here I can say one more thing is you will have a dependency on server team as well, right? Or your whatever VMware team or whatever team. What else?
Manual configurations, inconsistencies.
Okay, so again, yes, so inconsistency in configuration, right? And again, manual configuration. So basically CLI to every device, right? What else?
Not application aware.
So again, we don't care, even if it is not application aware in the LAN part. Do you care?
Security controls.
Security. Okay. So what is the issue with security?
Like we will not be able to restrict which servers.
Okay, so by
which...
default, it is gonna run on blacklist model. Blacklist security model. What is blacklist security model? Blacklist security model means everything is permitted by default. Okay, so this is what I'm talking about, routers and switches, not firewall. Okay, firewall is a whitelist security module, which is not gonna permit the traffic by default. Okay, so this is the issue. Okay, what else? So again, STP is the issue and block links.
Yeah,
Okay.
spanning tree.
No centralized controller. Okay, so again, no, if you talk about centralized control, so no centralized monitoring. Although third-party tool can do that. No centralized troubleshooting. Okay. So again, these are some of the reasons. Again, we can list a lot of reasons if you want. So guys, here, scalability, I'm gonna tell when I'm gonna talk about the architecture, I'm gonna tell you because again, it is very easy to scale here. Okay. Related to VLANs. So again, at that point, I'm gonna discuss that point. Okay. Related to here, VLANs, we in ACI, it is based on VXLAN. Okay. So VLAN is there, it's gonna use it for internal pathing and all that stuff, but basically your traffic is gonna be forwarded based on the VXLAN. Okay. So again, when we talk about VXLAN, so 2 to the power 32, these many of the VXLAN you can create. Okay, which is in case of VLAN, how many you will have in VLAN?
4096.
Okay, 4096. So it comes to around 16 million. Okay. Provisioning of new device. So again, we are having a zero touch provisioning concept here as well. So you just plug your device and boom, it's gonna take the configuration. Okay. Again, you are having a templates and policies which are configured to provide the consistency, to reduce human effort, all that stuff. Okay, so to reduce human error, human effort, all that thing. Security. Now here, this is a whitelist model. So here in ACI, nothing is allowed by default. You need to allow the traffic, okay, which is going to happen via a term which is known as contract. Okay, so you need to make the contract in ACI to allow the traffic. So nothing is allowed by default. Okay, ACI is a complete L3 environment. Okay, so there is no L2 links. So no spanning tree, no block links. So again, I'm gonna more tell you about when we talk about architecture in a minute. And then related to these all points. So again, you are having a Epic controller, which is a centralized controller in ACI, which gonna do the centralized controller, centralized monitoring, and centralized troubleshooting. Okay. The other key benefits are it gonna remove your complexity of 3-tier architecture. So ACI is gonna work on 2-tier architecture. So I hope you guys know what is 3-tier and what is 2-tier architecture. Can anyone tell me, guys?
Three-tier is basically access, distribution, and core layers.
Right.
Core distribution access.
So core, aggregation, or you can say distribution, okay, and access. And what is 2-tier?
Spine leaf.
Okay, so it's gonna be spine leaf architecture.
The aggregation and core are on the same layer.
So you will have aggregation and core on the same layer, which is gonna be spine layer. Okay, so it's gonna combine your core and aggregation or distribution layer, and then your leaf layer is gonna be access layer. So now let's discuss about the 2-tier architecture that ACI is used. Okay, so it is going to be spine and leaf architecture. Okay, so spine is going to be your backbone layer, and leaf is going to be your access layer where your end devices is going to connect. Okay, so if I talk about the basics of ACI, so if I assume that you will have zero knowledge in ACI, so I will say one statement which is partially correct, okay, at this point of time. So you will have the devices which comes in the spine layer. So for example, this is one device, this is another device. And guys, here these devices are your switches. Okay, so devices in ACI are switches. Okay, and related to spine layer, you will have two. So again, let me first tell you the models. So you will have a NEXUS series. So can anyone tell me what is special in the NEXUS series?
They're very powerful devices.
Okay, what else?
They have a huge port capacity.
Right, what else?
They are used in data centers.
Yes, what else? They have a very less, you can say, latency, right?
And see very
nearly related to line rate where your packet is going on the line speed.
Yeah, high bandwidth throughput.
High bandwidth throughput, right?
Modular devices.
Modulars, non-modulars, right? So again, when we talk about the spine layer, you will have two dedicated series. Okay, one series is known as NEXUS 9500 series, which is a modular series. I hope you guys know what is modular. So the switches where you can insert the modules, those type of switches are known as modular. And then there is another which is known as fixed. So those are the switches which where you cannot insert a module. Okay, so those are the fixed switches. Okay. So NEXUS 9500 series switch, and then you will have one or two models there, which is from NEXUS 9300 as well, which is known as baby spines. Okay, so these are used in where you don't need much capacity of ports and all that stuff. So very I can say where the less number of devices are there. Okay, so again, but 95% of the time, 90% of the time, you will find the spine switches from the 9500 series switches. Okay, so again, they can go up to from 10G to 40G to 100G to 400G. Okay, so this is a capacity of the switching or the bandwidth they can go up to. Okay, so 400G they can go. Okay, so these devices we use in the spine layer. Okay, and these are your switches. Okay, they can run. So again, when we talk about NEXUS, there are two different modes over which NEXUS can run. One is NXOS mode and another one is ACI mode. Okay, so these devices can run in both the mode, but one mode at a time. So either you can run them in the NXOS mode, which is a normal mode like your NEXUS 7000, 7700, 5000, 5600, and 2000, 3000, 4000, all those devices run. Okay, or else they can run in ACI mode. Okay, so but again, at one time they can run in one mode. So can anyone tell me why this is the case? Why they, again, if they are a specialized series only for ACI, why they are running in the NXOS mode? Why the Cisco give that functionality? Any guess?
At any point, customer wants to move to ACI, it should be flexible for them.
Yes. So basically what is going to happen before running the ACI? So again, there are two concepts. One is network centric model and another one is application centric model. Network centric model is the previous model where your main focus is on the network devices. So your application traffic is going to move based on the network devices configuration that you do. But what happen in application centric model is you gonna make your application centric approach. Okay, so your application is important than your network infrastructure, and then your devices is gonna be placed in that way, or the configuration is that gonna be placed in that way that it supports the application. So again, when you run your devices in application centric mode, you need a lot of planning. Okay, which cannot be done in a one day. But today, your organization is doing the hardware refresh. Okay, so they need to change the hardware. So they can buy the hardware which can run right now in the NXOS mode, but later on, like for example, you need 2 years to do the planning and all. Okay, so later on you can run in ACI mode. So that is the why they put it the option of using it both the modes. Okay, so that is how you can do it. Okay, and then related to your leaf switches, so there is a series which is known as NEXUS 9300 series. Okay, there are a lot of models. Okay, it is around 30-40 models are there in these series. For NEXUS 9500, there are four models only. Okay, which is 9504, three models only. 9504, 9508, 9516. Okay, it depends on the slot capacity only. But for 9300, you will have a lot of devices which is present. Okay, and this is going to be for your leaf layer, except only one or two models which can also work in spine layer. Okay, so again, that is the case. Now, to implement the ACI architecture or ACI connectivity options, there are some rules. Okay, first is your spine layer. So, and then you will have a leaf layer. Okay, so I'm just making 2 spines and 3 leaves. Okay. So again, first of all, the first condition is every leaf should connect to every spine. Okay. So this is, for example, my first spine is connected to all the leaves. And this is my second spine, which is connected to all the leaves. So this is the first rule that you need to follow. The next rule is you cannot connect 2 leaves together. Okay, so this connection is not allowed. Okay. Other rule is you cannot connect 2 spines together. Okay, so that is also not allowed. Okay, if you are running your ACI in a single pod, then everything is gonna go into a connect to your leaf. Okay, so again, if this is your ACI environment, or it is known as ACI domain, and you will have a traditional network. Okay, so this is, for example, your edge router in your traditional domain where you are not running ACI. Okay, so you can connect your edge router to your leaf. Okay, or if you are having a edge switch, you can also connect it to your leaf. Okay, or if you are having a firewall, okay, that you also connect to a leaf, or if you are having any service device like load balancer, IPS, whatever it is case. Okay, so this is going to be happen for the single pod. But if you are running multi-pod or multi-site, then multiple ACI domains can connect via spine. Okay, so then your connectivity is like that. So for example, these are 2 spines. For example, 2 leaves. And this is your one ACI pod and another one is here. Okay. And then you will have an interpod network, which is known as IPN network, where you will have some routers which are connection, and then they're going to connect it to your spines like that. Okay. So again, there are a lot of requirements for this interpod network as well, like MTU requirements. You need to enable bidirectional PIM and all that type of stuff. Okay. So again, we're going to talk about when we do when we see the theory of multipod and multi-site. So let's concentrate only on the single pod. So single pod point of view, for example, these are my leaves. So I already told you how the connection is going to happen, right? Now these middle connections are all L3 links. Okay. So there is no L2 connection. Okay. And the protocol that they're going to run is integrated system to integrated system protocol. Okay. And guys, these L3 links and this protocol running is automatic for you. You don't need to do any configuration to run this. Okay. Even the IP is going to take automatically. Your APIC is going to connect to your leaf. And when you start your APIC and you initialize your APIC, you will give the pool of IP. Okay, which is going to go in your complete ACI domain. So all the IPs is going to be associated with this pool. So whatever, because again, if you need to have a L3 links and if you need to do the routing between them, you should need a IP on every point, right? So every point you need a IP. So this IP is automatically allocated for you. You don't need to configure it. Neither you configure it. Okay, it will be automatically based on the pool that you give. Okay, on your APIC. You can give multiple APIC. You can run multiple APIC to provide redundancy. Even Cisco recommends minimum, not even recommend. It is a condition that you need to run minimum 3 APICs. Okay, these 3 APICs can connect to any leaf, whatever you want. So that is also not the case. Okay, and then they're gonna do, so again, this is ECMP, okay, equal cost multipathing, because if you see between any 2 leaves, you will only one hop away. Okay, so because again, then you design the topology, they put the restriction in that way that every leaf is gonna be one hop away from other leaf. Okay, and then you're gonna make a VXL tunnel. Again, your VXLAN tunnel is going to be created automatically between the leaves, all the points. Okay, so again, for example, from here to here, you create one tunnel. From here to here, you create one tunnel. From here to here, you create one tunnel, like that way. So between so your every leaf is a tunnel endpoint of VXLAN. Okay, those who don't know what is VXLAN, how it works. So again, I need to explain it from the basics. So we do it in the class. Okay, so this is how your packet goes via from one leaf to another via spines. Okay, there is no direct connection. If you put it, there is a protocol which is known as miscabling protocol, which automatically kicks in and it's gonna disable your link. Okay, so again, that is the rule. So tell me guys now if you have any doubt, any question related to this.
Can you just go to the previous slide? I just want to take a screenshot. No, the previous one to that.
Which one?
Yes, so. Thank you. Is there no way you can share these? Because it gets a bit difficult, you know, taking screenshots. If it's okay.
But again, these are just very basics. I'm not sure. I even never exported them to anywhere.
I'm just saying, going forward, even in the classes as well. You know, it's just good to keep a.
So I will try to find a way, but again, in
Okay,
classes you will get the recording as well, so you can automatically take the things with the recording.
Okay, I have a question on the last slide, please.
Yes.
The two domains, how did you connect it? With the traditional network on the top?
Okay, so this is going to be Interpod network. This is not a traditional network. This is a special type of network which needs some requirements. There are some requirements like you need to specially enable the jumbo frames. Okay, you need to enable the multicasting over it. Okay, so there you need to run a protocol, routing protocol between them, which is OSPF. So again, it is not a traditional network.
Okay, and down there, these red links, you said they will automatically get the IP addresses, or
yes,
only the ISIS will be automatically configured?
So only IP addresses is also what you will get automatically. Your ISIS is also get automatically configured. This VXLAN tunnels, these red links are your tunnels, okay, which is also automatically configured for you.
Okay, and if we want to change the IP addresses, then?
So again, you can change it, but again, it is not recommended to change it because that is going to be getting via DSCP. Okay. And you can fix those as well. Okay, so they're not going to change. So whatever the pool you configured in the initial script, in the initial configuration of your epic, it's going to be changed. It's going to be based on those pools. And you don't even need to touch them because again, there is nothing you need to configure there. Okay, automatically everything is going to configure. So let it be automatic.
Is there no alternative of like NEXUS in the Catalyst switches? Like we also have Catalyst 9600, 9500 switches. So can't they be used with the ACI?
No, you can't do.
Only NEXUS.
So NEXUS, again, in the NEXUS, you will have a lot of series. Okay, if I talk about NEXUS series, you will have 93, 90, let me start from the first. So 9500, 9300, 9100, then you will have 7700, 7000, 56, 55, 5000, 4000, 35 also there, 34, 33, 3000. Okay, then you will have 2600, 2500, 2000, 1000 V. So these many series, these are all series, okay, that I have written. Then you will have a lot of models in every series, but only these two series supports ACI. Rest all the series supports NSOS only.
Okay.
So ACI plus NSOS is only for these two series of the top.
Thank you.
Yeah.
I have one query. Like in terms of scalability, how many spine switches or leaf switches, is there any limitation?
Yes, so there is a limitation, but it depends on the epic. Okay, but that is a very huge number. No one even touching those number as of now. I forgot the number, but again, you can see the data sheet to find the number.
If you're using the from NSOX to ACI, do you need a different license?
Right. You need to have a license for that.
And this whole process of configuration, we do any ACI, any GUI, or we do it CLI? How we do?
So again, you will have three options: CLI, GUI, API, whatever you like. So API is your programming interface where you can write the program either in Python, automation, whatever language you are comfortable in. GUI is directly GUI, you can do it. CLI, if you like your traditional CLI. Any device you can do the CLI and do the configuration as well.
Do we need any license, specific license for GUI and API, or it's
no. Inbuilt.
Okay.
Yeah.
And is there a limit on how many leaves you can have from one spine?
So again, not related to a particular spine, but into a complete domain, there is a limit. But again, that is a very huge limit. So do not worry about that.
Okay.
I have seen 8 spines with 50 leaves. Okay. And I cannot comment on the company name, but it is in the top 5 Fortune companies in the world, top 10 Fortune companies. Okay, so that scene. I was managing around 15 data centers which are running directly on the ACI, and we are allowed to only work on API only. We're not allowed to work on CLI and GUI. Okay, guys. So this is all related to ACI. Okay. Now, NEXUS. So let's now come to NEXUS. So NEXUS, we need to take 2 topics. One is so basics of the topics. Again, if I take the topic, it's going to be a one-day complete topic. So VDC and VPC. Okay, so first let me tell you what is VDC. So again, NEXUS means you are having a NEXUS series switch, okay, which is running in the data center. So there's a concept of VDC, which is only going to be present on your 77K and 7K series. Okay. So 7700 and 7000. Okay, these series only support this concept, which is known as virtual device context. So basically it is your, what is going to happen. So for example, you are having a one complete modular switch. Okay. From this series. Okay. And now you can divide this physical switch into your logical switches. Okay. So when I talk about logical, I am drawing it with the dotted lines. So again, guys, I am just telling you the basics because again, complete VDC, if I take, it will take around 2-3 hours to do the complete topic. Okay, so for example, here I made 4 logical switches out of 1 physical switch. Okay, so again, there is a limitation which depends on your supervisor engine. If your supervisor engine is of SOUP1, okay, which is the first generation supervisor engine, you can create 4 VDCs, okay, which means 4 logical switches. Okay, then if you are having a SOUP2, which is second generation, then you can create 4+1, which is known as 1 is your admin VDC, which only works for administrative task, and then 4 is your data plane where you can make it for your data plane. And then you will have a soup 2E, which is enhanced of the second version, where you can go with 8+1. Okay, so 1 is your admin VDC and 8 is your, so you can now divide your switch into 8 different virtual or logical switches. Okay, so this is what VDC do for you. Okay, now when you divide it into the logical switches, now through the backplane, they cannot be able to communicate. Okay, so now they will act as 4 different switches. If you want to do any communication between them, you need to put a cable from one port to another port in the front end. So through the backplane chassis, they cannot communicate. You need to have a physical cable to do the communication. Okay, now related to your shares. So again, there are different type of resources. One is CPU, for example, if we talk about, so CPU is gonna be equally divided between the number of logical switches that you create. Okay, related to your interface or line card configuration. So for example, if you are having a particular line card in your physical chassis, which is a, for example, 32 port line card. I hope everyone knows what is line card. Again, if you not know, I'm gonna discuss. So again, line card is a module, interface module. Okay, where you will have a ports to plug your devices. So for example, if it is having 32 ports. Okay, so just randomly I put the ports. So again, every set of ports is based on your ASIC, whatever ASIC is there. So for example, this line card is having 4 ports, which is connected to one ASIC. Okay, these 4 is connected to one ASIC. Then these 4 is connected to another ASIC. So then you can move these ports as per your ASIC to any of your logical switch. So for example, this I put it here. Okay, this I can put it here, or else I can put the complete line card into a one switch as well. Okay, so again, it line card wise, it depends on your choice. How you want to send your traffic, how you want to put your ports into different switches. Okay, you can reuse your what I can say naming conventions. Okay, you can reuse your VLANs between your logical switches because now they are separate switches. Okay, so VLAN 10 in switch 1, VLAN 10 in switch 2. You can configure it. Okay, so like that way. Now you can ask the question if you want in this. Any doubt, any question?
What is ASIC actually?
ASIC is a application circuit, okay, which is gonna provide the line rate to your ports. So your port is gonna connect internally via a bus to a particular ASIC. Okay. Now I will tell you what are the use cases of these. Why you want to do it actually. Okay, so here, can you try to guess, guys? What are the things you can do with this? Why you need to break a physical switch into different switches? Any guesses?
To use like multiple networks.
Security.
Cost
Okay, so
and
if you have, for example, offices to connect with another, like you have a company divided into office and production. So half of the switch or half of the like ports could be used for offices and half of the ports could be used for like production, and those will be completely separate and secure.
Okay, so one is to segregate the traffic between your different departments, I can say, or your LOBs, okay, line of business, right?
Exactly.
Yes, so this is one thing. Now tell me data center point of view. One most important use case.
You can use VRFs, actually, the same IPs you can assign.
So guys, see it here.
You can
Try to
save the
understand.
rack space.
Wait.
space.
Yeah. Wait. So someone said about VRF. So VRF, if we talk about VRF, that is not at the L1 level. So here what we are doing virtualization at L1 level, okay, which is layer 1. If I want to make a VRF, I can make a VRF in a single switch as well. Okay. Yes, tell me guys now.
You can
Space and
save the
energy.
rack space size.
So what is Rex? What is Rex space? Physically, it's not gonna do anything.
Like if
This is
No,
logically you are doing it.
If you have to get different switch, then it will take a rack unit, right? In the switch.
you can use your free
But what
ports.
you are
In the data center's perspective, it will take a space if you want new switch to be installed. So in the same switch, you are making it logical, right? So it will save the rack space.
You can
but
save
rack
your
space
ports
saving
actually.
is not my rack space saving is okay, but that is not my
zone creation like DMZ and military zone. And
okay. So again, if it is your security related, but again, will you create the zones on the switch? You will do it on the firewall here, not on the switch.
Yeah.
So again, firewall is also having a same concept. If you guys know, what is this concept known in firewall?
Context.
Yes. So firewall is also having this concept, same concept. So tell me guys, one very good use case.
I think, Shashank, it's a procurement and license part that will be reduced, right? If we are going with
But
more
again, you
number
need
of
to buy
physical.
PC license if you do it.
Multi-vendor hosting.
So what costing? How are you gonna reduce the costing?
No, so say for example, you're a hosting company and then you're hosting different environments. So you can have like one VDC for company 1, which is paying for one set of resources, and company 2 for another set. They can give them another VDC.
Okay, so I can.
You can save one management IP.
Wait, Prashant. Let me speak. So basically, I can do one company on one switch, right? That is what you are saying, Mohammed, right? So basically, you are saying about multiple customers, right? Multi-tenancy.
Exactly.
So yes, multi-tenancy you can do. Okay. What else?
Connecting different server.
Different
server.
Servers. How? What it make a difference? You can connect it either one switch or different switch. Okay, so one more use case which is most commonly used is, for example, in the data centers. I have a Nexus, this one, okay, which is Nexus 7K1. Okay, this is my first device, and then I am having one more device, which is second device. Okay, I can make 4 different switches out of it. 4 different switches out of it. Okay, and now this is a single device, and now what I can do is I can run core layer distribution layer out of it. Okay, so now logical switch can run like that as well. And guys, if you want, you can run DMZ as well, but again, DMZ most commonly you will find it on the firewall. So this way also, by making 2 VDCs, even if you're not, it's again your choice. You don't want to divide it into 4, divide it into 2 only. That's it. Okay, so they can be redundant, and then your core and distribution will be on the same device. Getting my point, guys?
Yes, that's good.
Yes, and even if you are having multiple distributions from multiple building, you can do what thing is, you can make a switch to, like for example, core is there. Okay, so core is gonna be wherever it is a core. So you will have another switch for core. Okay, but you will have multiple distribution as well. Right? Which can provide redundancy to each other. So that way also you can set this up. So these ways it can save your cost, it can save your rack space, it can save your cooling power requirements, all that stuff. Okay, so this is the benefit of it.
So we can do the same on 9500, I guess.
You cannot do it on 9500. Only the series supports the VDC 7700 and
I see.
yours is 7000.
Okay.
You cannot do it on 5000 series. You cannot do it on any other series. Okay. So this is only is supported on this. Okay. Anyone having any other question before we move on the last topic? Okay. So last topic of the today is VPC. Again, guys, I need to discuss a lot with this, but again, cannot go everything in this one. So VPC is the virtual port channel. Okay. So first of all, let me tell you what is port channel. I hope everyone knows what is port channel. So port channel is between the devices. You will create, for example, two links. So what is the advantage of port channel and what is the disadvantage of port channel? Tell me quickly.
Can I get two links into one logical link?
So it's gonna bundle it to so that this is your physical topology, but logically it will look like this.
Yes.
And by the way, guys, port channel, ether channel, okay, link aggregation, okay, lag, mlag, okay, and then what else is there? There's a lot of the terms which are interchanging, which represent to the same technology. Okay, it depends on the vendors how they use it. Okay, anyways, so logically it's gonna represent like this. So what is the advantage?
Redundancy.
Increases the bandwidth.
Increase the bandwidth.
How it increase the bandwidth?
You use multiple links to send the data.
So, but how it increase the bandwidth? So if I'm combining these two links to, for example, these are my two 1 gig links. Just a second, guys. And if I'm combining it into one, then this is going to be 2G link or 1G link.
It's gonna be 2G.
This is gonna be two 1G links.
But now the question is two terms.
If one link goes down,
another is bandwidth. Now tell me what is the throughput and what is bandwidth here?
Throughput is how much data are you sending on this link in a specific
So how much?
time.
Tell me.
For example, you send data on like 1 gig, it will immediately go. You send 2 gig, it might be like 1 gig go on the first link and the 1 gig go on the second link.
So again, throughput is going to be 1 gig plus 1 gig. What is bandwidth?
1 gig, I guess. It will.
Okay, so those who not able to understand, let me tell you. This is your city number 1. This is your city number 2. Okay. And you are having a highway between that. Okay. This is a highway. So this is not a link. This is a one road only. And cars are going on this highway. These are your cars, which is going from city 1 to city 2. Okay. And then as per your country regulation, there is a speed limit of 100 Mbps. 100 miles per hour or 100 kilometers per hour, whatever is used in your country. Okay. So you cannot run more than that speed. Okay. Now, what is going to happen? Now there is one more highway which is added to these two cities. So cars is going to start going on that highway as well. So what happened? What is the end result of that?
You just decreases the load of one to share the to share it between both, so it just makes it quicker for traffic to go, or it shares it between.
Okay, so again, end result is your more cars can go
with the same speed.
Okay, but limit will be limit. So your limit no car can go above 100 miles per hour. Okay, this is a hard code limit which is present in the car. So no matter whatever accelerator you are pressing, it will not go beyond that limit. Okay, so now the same concept, forgot about city. So this is my one device and this is my another device. So over one link, I am having the hard code bandwidth, which is of 1 GB per second. Okay. And here also 1 GB per second. So more number of packets can go, which is throughput. But your bandwidth is gonna be 1 gig only. Your bandwidth is not gonna increase in any case. Getting my point, guys? You can send more number of packets, but if a flow is taking more than 1 gig of packet, then it will buffer that packets on your device. It will not go above 1 GB per second. Okay. So this is port channel, and guys, port channel will provide. So again, normal port channel is going to provide you link level redundancy. What is link level redundancy? That one link goes down, so another link can take over your traffic. But your normal port channel is not going to provide you device level redundancy. If your device goes down, other side, what is going to happen?
Your link will be down.
Yes, your traffic will not forward it, right? Basically. So
Yep.
now to overcome that limitation, which is known as device level redundancy, there is a concept which is known as virtual port channel. Okay, this V represents virtual. So what does it mean? It means on the upstream, you will have two devices, and now your downstream device, instead of sending the link, instead of putting both the links to a same device, previously you are having both the links to a same device, right? Now here, instead of putting your both the links to the same device, one link will go to another device and you will make a port channel. Okay, so this is known as VPC. Again, this is what happens in case of NEXUS. It is known as VPC. Okay, in your 6500 series switches and 45 traditional cat OS, you will have this concept as well, which is known as VSS. There also you can do it, but there is a very minute difference which is present. Okay, here what is gonna happen is when you do it for Catalyst OS, this is one device is gonna be active and another one is gonna be standby. Okay, but here in VPC NEXUS, your both devices is gonna be active. So you can send the traffic over both sides. Your control plane is gonna be active, and there is a link between them which is gonna sync your control plane. So again, guys, this is just a 5 or 10 minutes overview. Again, we have lot of things in VPC which cannot be covered in single. So again, this is a brief overview of why we use this thing. Okay, so now here what you are getting link level redundancy as well. If your one link goes down, another link can take over the traffic. Now you are getting device level redundancy as well. If your one device goes down, you can send the traffic via another device as well. So now, if you have any question, let me know. All good, guys? Okay. So this is all I need to tell you with the basics. So again, the main motive of the demo class is to understand how the trainer is teaching, what is his way, and if you're able to comfortably understand that. Okay. Again, these topics, VPC, when I do the class, I take around 4 days to do the complete VPC. Okay, where I go from scratch and then I'm gonna go to the advanced level. Okay, so that's all with the class of today. If in case you are having any doubt, we can take the questions in next 2 minutes. After that, we're gonna wrap it up for the day. So do you have any questions related to course, related to anything,
Yeah.
course content?
From next week, is it 6 o'clock India time you're going to start, or 6:30?
Yes. So it is gonna be, so what is the time mentioned in the website? It is gonna be on that time, 6:30, I think. I'm not sure
6:30.
whether it is 6 or 6:30.
Yeah.
Okay. So
No,
it
because
will,
on the website it still says 8:30.
yes.
Yeah. So yeah, if you could let us know if it's 6 or 6:30.
So the next 7K, they are going to be obsolete.
7K, yes. This year they put not obsolete, but end of sale announcement they already made. I think in the last year they made that announcement. In 2021 they made the announcement of 7K, not for 7700.
And the
And
5Ks?
VPC is gonna be supported. So 5Ks you will have different series, right? Right. For example, 5Ks are obsolete, but 5500, 56 are still running.
Okay.
And VPC is supported in all the series. Okay, 9K, 7K, 5K, 2K, 1K, all the series supports VPC.
So is there no alternative for ACI in Catalyst switches? Because I was previously working with Catalyst 9500, 9600.
No, nothing. You cannot do it.
Okay.
So till January of this year, there is no support. I'm not sure about the current situation. You can check the data sheet, but again, there is no support for that.
Thank you.
Yeah. Okay, guys, anyone having any other question before we wrap it up? So again, guys, there is a link in the chat where you can contact if you want to talk about the fees, all that stuff. So there is a WhatsApp link, there is an email link. You can take the screenshot. You can note down the numbers, because once the meeting is over, this chat is going to be closed. Okay. So note down that thing. Also on the website, you will have the links, okay, to connect. Also from the email, what you got it, okay, you will have the links to connect. Okay, so you can connect from anything. Okay, this is going to be topology that we're going to use throughout our course. So again, everything you will find it here. If you have any doubt, any question, you can contact on the below numbers, which you have it in the chat. Okay, guys. So thanks a lot for joining the 2 days session. I hope you like it. Okay. And we will meet it on the next weekend. Again, guys, I only take limited number of students. So first comes our services. After that, we're going to close the batch. Okay. So thank you everyone for joining today. Have a great weekend. Thank you.
Thank you.